Hey everybody, today we are going to be taking a look at section 6.4, multiplying and dividing monomials. Okay, let's start with just talking about how you would pull this off. When multiplying monomials, coefficients multiply with one another. And variables multiply with one another. Okay, let's take a look at what that means. Let's take two monomials. Remember, monomial is just a polynomial that only has one term. So we're going to start with something real simple with these monomials, and then later on we're going to branch off into much larger polynomials and how we multiply those. Let's take 3x squared. That's my first monomial. And I want to multiply it by 2x. That's my second monomial. So I want to multiply these together. Let's take a look at what this means. Now this 3x squared, remember that 3x squared just means that I have 3 being multiplied by an x, and that's multiplied by another x. Okay, 3x squared means 3 times x times x. And then I have 2x. So that's just 2 times x. And I want to multiply that with my 3x squared. So I'm multiplying all of these together. So we have 3 times x times 2 times another x. Because this is all multiplication, you can rearrange these. It doesn't matter what the order is. Right? 2 times 3 is the same as 3 times 2. You get the same result. So if it's all multiplication, you can rearrange each of these pieces and it won't affect the answer. I'm going to rearrange this so that all of my numbers are together and all of my variables are together. So I'm going to put the 3 times 2 next to each other over here, and then my x multiplied by x multiplied by x, I'm going to put those together on the end. Okay, let's go ahead and simplify some of this. 3 times 2 is 6. And x times x times x, well, there's another way we can write that. We can write that as x cubed. So the result of 3x squared times 2x is 6x cubed. And if we go back, it said coefficients multiply with one another. So really, the coefficients 3 and 2 multiplied with each other to give me 6. And the variables multiply with one another. So this x squared multiplied by x gave me x cubed to give me my final result of 6x cubed. Let's take a look at some examples. Let's multiply the following. Let's take negative 4x cubed and multiply it with negative 2x squared. All right. Now, to pull this off, we would multiply the coefficients together. Negative 4 with negative 2 gives me positive 8. Now, for x cubed times x squared, we can use our exponent law, where when we're multiplying powers of the same base, we can add the exponents. Well, here, the base is x. Our exponent is 3 and 2. We would add it together to give me x to the power of 5. And that's it. That's our final answer. Let's do another one. Let's take 3x squared y cubed z and multiply this by negative 4 x cubed y. Let's multiply that out. Okay, so again, bit by bit, we're going to multiply these out. The coefficients with the coefficients. 3 times -4 is -12. X squared times x cubed, right? We went over this before. We can add those exponents, so that's x to the power of 5. Y cubed times y. So remember, this y has this invisible exponent of 1. So y cubed times y is y to the power of 4. And then this z, there's no other z's to multiply it with. It doesn't go away. It's still there. So don't forget to include the z at the end. And then that's your final polynomial. Okay, let's take a look at division. So when dividing monomials, coefficients divide by one another, and variables divide by one another. So it sounds pretty much the same as multiplication. The coefficients go together and the matching variables will interact with one another and go together as well. Let's take a look at an example. 6x cubed, 3x squared. Okay, so we have 6x cubed divided by 3x squared. Let's take a look at what's going on here. This 6x cubed is really 6 times x times x times x. And on the bottom, this 3x squared is really 3 times x times x. Now when we're dividing, 6 divided by 3, well, we know that's 2. But what about this part here? When we're dividing x with another x. X divided by x. So anything divided by itself will give you 1. Okay, so this and this divide out to give you 1. Okay, so they cancel each other out. X divided by x over here also cancel each other out. Okay? And so we're going to end up with 2 times 1, so no change there, times another 1, no change there, and then we still have this 1x remaining. So we're going to write that out. So that's 2x. So you can see when we're dividing, these variables end up kind of canceling each other out, depending on the degree of that term. We'll do another example to see how that works. So 2x is our final answer. Let's try another set of examples. Let's divide the following. I have negative 27w to the power of 5, and I want to divide it by 3, w squared. So, just like it said before, coefficients go with one another. So let's do the negative 27 divided by 3. So negative 27 divided by 3 is negative 9. And then w to the power of 5 divided by w to the power of 2. Again, you can use exponent laws that we learned before. When you're dividing powers with the same base, you can subtract the exponents. So here the base is w. And the exponents are 5 and 2. So 5 minus 2 is 3. So negative 9w to the power of 3. That's our final answer. We'll do one more example. Let's do a big one. 64. A to the power of 17. B to the power of 3. C to the power of 9, and F to the power of 2. And we want to divide this entire monstrosity with negative 16. A to the power of 5. C to the power of 5. And F. All right, let's divide this thing out. 64 divided by negative 16 is negative 4. A to the power of 17 divided by a to the power of 5. So again, just use exponent law, okay? The base is a, and my new exponent is going to be 17 minus 5, which is 12. So a to the power of 12. B to the power of 3 divided by, oh, well, there is no b on the bottom. So no changes there. It just stays as b to the power of 3. And then c to the power of 9 divided by c to the power of 5 is going to be c to the power of 9 minus 5, that's 4. And then finally, f squared divided by f. So again, if it doesn't have an exponent, it really has an invisible 1 as the exponent. So f to the power of 2 divided by f to the power of 1 is just f to the power of 1. So that's a single f. And there you go. That's the final answer. There's your polynomial. All right. That's it for today. Thanks for tuning in. I'll see you in the next one.